Good day, everyone. My name is Joseph Isnabel, so I'm going to be the first reporter in the ABM 42. So today we'll be going to discuss the important project management techniques, the critical path method, or what we call the CPM, and also the program evaluation and review techniques, or PERT. So as you can see in the first slide, um, the title is the PERT dash CPM. So this is a project techniques that focuses on identifying the longest sequence of dependent tasks within a project. This longest sequence is known as the critical project. Um, Determines the overall duration of the project. PERT, on the other hand, is described as a probabilistic project management tool that is used to uncertainty into project planning. So, next slide, please. So, this slides deeper into the PERT and a project management. So, I'm going to be discuss the PERT. So, PERT is utilized to identify the time it takes finish the particular task or activity. It's a it's a valuable system that aids in the proper scheduling and coordination of all overall project schedule. Interesting, the project evaluation, review, and technique was developed by a was developed by in the U.S. Navy. So it was developed in the U.S. Navy to manage and deploy submarine missiles programs of their special how they call it, a special project office, highlighting and significance in managing complex. Also, undertakings these slides also show a basic per chart. So, moving on the third slide, this illustrates the process of creating a per chart. So a flow chart is used to visually represent the project evaluation review techniques. Nodes in the chart represents the events, indicating the start of end of the activities or tasks. So directional lines or arrows that as can you see in the in this slide depict the tasks that need to be completed, and the sequence shows the flow of the projects. So as you can see, wala siya katong sa atong nakuan sa una ni sir katong wala siya katong sa tree bitaw nga sa tree nga something datong na din mag-solve that to, pero kanilang siya kay nakapokus siya sa per chart, and then naka-incline na to ang mga tasks, ang mga activity nga buhaton, nag-start siya up to the end. So, moving on, let's go to the fourth slide. So this slide provides the steps in implementing a bar chart. So, this time, we're going to mag-implement na sa per chart. So, first, this is a very crucial to identify all the different tasks needed to complete the project. So, make sure to add this task in the right order and indicate the task in the right order, and indicate the duration of each task rather. Next, you need to construct a network diagram using arrows represent the activities and nodes as a milestone of event. Finally, the very critical part, what they said, which is the longest sequence of the activities and the potential slack of a fluid in the schedule should be determined. So, next slide, please. And the next slide, so we're going to discuss the advantage of having a PERT or a PERT chart. So, there are several advantages to use a PERT in a project management as outlined. First, it makes the project planning more manageable. Yes, mahanay gid siya when we're going to use the per chart by breaking down the complex projects into smaller and interconnected tasks. So thirdly, PERT is very useful even when there is a little or no previous schedule data available. Why? Because it allows for probabilistic time estimates And lastly, it enables a project managers to better estimate and determine more defined project completion date. Um, Next slide. So in this slide also, pag if there's a pros, also there's a cons. So here are the cons. So despite the benefits of the PERT, there also has some disadvantage as shown in our PPT. For the complex projects, many find PERT hard to interpret. Yes, it's really hard to interpret if you're really not familiar about the PERT chart. And other tools like Gantt chart might be preferred by some project managers because it may easy to use to others. And secondly, it can be tedious to update, modify, and similarly, it can be tedious maintain the PERT diagram, and especially for longer projects like numerous dependencies. So nga na like maglisod sila ng part. And finally, it entails a subjective analysis of activities. And for those who are less experienced about the pie chart or bias, this may negatively affect with the project schedule's accuracy.
CPM, or the critical path method, also known as the critical path analysis or CPA, is a project management technique used to schedule activities and identify the critical path, which is the longest sequence of activities that must be completed on time for the entire project to be finished on schedule. It helps determine the minimum project completion time and pinpoint critical tasks that cannot be delayed without affecting the overall project timeline. Uh, what is CPM? So, a project management technique. CPM helps plan and manage projects by identifying critical and non-critical tasks. Determines the critical path. The critical path is the longest sequence of activities that must be completed on time for the project to be finished on schedule. Helps estimate project duration. CPM helps determine the minimum time required to complete the project. Identifies critical tasks. It highlights tasks that, if delayed, will delay the entire project. Uses a network diagram. CPM often uses a network diagram to visually represent the project's activities and their dependencies. Example: there's a scenario where planning a construction project. Uh, the project is building a new office building. So, for example, we have A, B, C, D, E, F, G, H, I. A, which is to design and planning for 4 weeks, estimated 4 weeks. So B, secure permits for 3 weeks, dependent on A. C, site preparation 2 weeks, dependent on B. D, foundation 5 weeks, dependent on C. E, for framing 6 weeks, dependent on D. And F, roofing 4 weeks, dependent on E. And G, interior work 8 weeks, dependent on E and F. And H, interior finishing 3 weeks, dependent on F. And finally, I, landscaping 2 weeks, dependent on H. So there's a critical path and non-critical path. The critical path is the sequence of tasks with the longest total duration. In this case, it would be A to B to C to D to E to F and to G to H and to I. So the total duration is 4 because A would be 4 weeks, a total of 4 weeks, and 3 for B, total of 3 weeks, and so on and so forth. 2, so 4 weeks plus 3 weeks plus 2 weeks plus 5 weeks plus 6 weeks plus 4 weeks plus 8 plus 3 plus 2 weeks is equals to 37 weeks. Any delay in this task will directly affect the project completion date. And we have non-critical path, tasks that have slack or float meaning they can be delayed without impacting the final project completing date. For example, if task L landscaping is delayed, for task I landscaping is delayed, it might not immediately impact the overall project completion. So we have an advantages of CPM and we also have disadvantage of CPM. So the advantages is one, enhanced project planning and communication, visual representation, improved communication, clear task dependencies, improved planning accuracy. And two, efficient resource allocation and management, optimize resource allocation, reduce bottlenecks, and resource optimization. And the disadvantages of CPM, the critical path method, has several disadvantages, including its complexity, rigidity, potential for resource ignorance, and the need for detailed information. It can be time consuming to set up, especially for large projects, and lacks the flexibility to adapt to unforeseen circumstances.
Good day, everyone. I'm Jatrice Tanggihan, and I will be doing the project scheduling or finding the critical path. So, in this example, we will be working with this activity schedule for a project. So, we will be constructing a project network, doing forward and backward passes, determining the project completion time, calculating slack values, and finally stating the critical path. We will be using the node convention here as you'll find in Quantitative Methods for Business by Anderson, Sweeney, and Williams. A is the activity being described, and T represents the expected activity duration or time. ES is the earliest time the activity can start. EF is the earliest finish time. LS is the latest start time, and LF is the latest finish time without extending the minimum completion time of the project. Now, we usually like to start with a sketch to make it easier when drawing the full network. So, we start with activities A and B because they have no predecessors, so they can start. Activity C needs A to be completed before it can start. D needs both A and B to be completed. E needs D, F needs C and E, and G depends on E. Since F and G have no successors, they go to finish. Here is the network with activity nodes, displaying the letters and times. So, let's do the forward pass. A has no predecessor, so its earliest start time will be 0 or right away. Since it has 7 weeks to be completed, its earliest finish time will be 0 plus 7, which gives 7. B also has an earliest start time of 0, and with activity time of 9, it will have an earliest finish time of 9. Now C needs A to be completed before it can start. Since the earliest finish time for A is 7, then the earliest time C can start is 7. With activity time of 12 weeks, C will have an earliest finish time of 12 plus 7, which gives 19. D, on the other hand, needs A and B to finish before it can start. Since the earliest finish time for A and B are 7 and 9 respectively, and D needs both of them to finish in order to start, then the earliest time D can start is D 9. In other words, the highest of the earliest finish times preceding an activity will be the activity's earliest start time. So D finishes at 8 plus 9, which gives 17. E here has only one predecessor, D, and so can start at 17 and finish earliest at 26. F has predecessors, C and E. Since the higher earliest finish time is 26, F can start earliest at 26 and finish at 32. G can also start earliest at 26 since it has only one predecessor, which is E, and G can finish earliest at 26 plus 5, which gives 31. Note here that although G is the last letter, it does not have the highest earliest finish because F has 32. So we say that the project's completion time is 32 weeks. In essence, the project's completion time is the highest and the earliest finish time at the finish node. So let's do the backward pass. Since the project's completion time is 32 weeks, the latest finish time for the activities at the finish node F and G has to be 32. That is, F and G cannot be completed in longer than 32 weeks. Next, we obtain the latest start times by subtracting the activity times from the latest finish times. So for G, the latest start time will be 32 minus 5 to give 72. For F, the latest start time will be 32 minus 6 and that gives 62. Now E has two successors, F and G. Their latest start times are 62, 26, and 27 respectively. As a result, the latest time E has to finish has to be 26 in order for F to start. In essence, when doing a backward pass, the latest finish time of an activity must be the minimum of the latest start times of its successors. Thus, the latest start time will be for E will be 26 minutes, 26 weeks minus 9, which gives 17. Now D has only one successor, E, so the latest finish time for D will be the latest start time for E, which is 17. And the LS will be 17 minus 8, which gives 9 for D. Activity C also has one successor, which is F. Therefore, latest finish will be 26 for C and latest start will be 14. A has two successors, C and D. The minimum of their latest starts is 9. So the latest finish for A will be 9 and its latest start will be 2. Activity B has one successor, D with latest start of 9. So the latest finish for B will be 9 and its latest start will be 0. The backward pass is now complete. Now, slack for an activity is defined as how long the activity can be delayed without extending or increasing the project completion time. And it's calculated as LS minus ES or LF minus EF. So the slack for A will be 2 minus 0 or 9 minus 7, which will be 2. The slack for B will then be 0. For C, it will be 7. For D, 0. For E, 0. For F, 0. And for G, 1. Note, for example, that activity C can begin anytime between week 7 and 17, and it can finish anytime between week 19 and 26. Therefore, C can be delayed for up to 7 weeks, and the project will still be completed in week 32. Activities B, D, E, and F, on the other hand, cannot be delayed at all without extending the project's completion time. So for example, if D is delayed by 2 weeks, then the project completion time will be extended by 2 weeks as well, from 32 to 34. The activities with zero slack are called critical activities, and they form a critical path, which is the longest path in the network. The critical path here is B, D, E, and F. And yeah, that's it. That's how we can find the critical path using the PERT or CPM.